So when we talk about oxidation, the idea of an oxidation reaction is it's any form of chemical reaction that has oxygen as one of its reactants. Okay? And we know that at like the apple browns, the skin of the actual white flesh inside browns when it comes into contact with oxygen. That is a chemical reaction that involves oxygen, therefore it is an oxidation reaction. But what we want to focus on, though, is the idea of combustion. And combustion, when we talked about it earlier, combustion is kind of like, when you think of that word, you think of like explosion or something burning, okay? When in fact, combustion is basically, with the help of oxidization, the release of a really large amount of energy. And we usually see a large amount of energy released when things burn, when things explode. When there is an explosion, okay, you cannot have an explosion without 3 key ingredients. And we call that the triangle of fire. Okay, because I know, it's kind of woo. Anytime a combustion reaction occurs, you have to have 3 things present. All right? So if we look at basically our triangle here, okay, we'll call this our triangle of fire. All right, we'll draw a little flame here, make it nice and pretty. There. Okay, I should do a lot of things. Now, one of the actual things that needs to be present in order for a combustion reaction to occur is you need to have an oxidizing agent. And that is normally in the form of air, because air has oxygen in it. Okay, you want to put a candle out in one of those containers, you put the lid on it. And very soon after, it burns up all the oxygen in that space and it puts itself out. Okay, or you want to put a candle out really quickly, you pinch the wick. By pinching the wick, you choke out the flame. Unfortunately, that burns you. But anyway, you're basically suffocating the fire. You're taking away the oxidizing agent. Okay? Which is why something like the movie Gravity was hilarious in a lot of ways, because you wouldn't get big explosions like that in space. There's no air in space. So the fact that there was all this fire, I mean, maybe if it was contained, if there was air inside the actual space plate, station, sure, whatever. But as soon as that makes contact with outer space, there's no air there. So there shouldn't be any sound or fire like that. Okay? You cannot have fire without air, without oxygen, to be specific, which is one of the main ingredients of air. The next thing you need is a type of fuel. You will not have a fire if there's nothing to burn. You can have all the air in the world. If there's nothing there that is flammable, you're not going to have a fire. Wood is it's a perfect case, or example of something that is a fuel. Okay, we know hydrocarbons are fuels. Gasoline, oil, stuff like that, very flammable. Okay, if there's a kitchen fire, if there's a fire in a frying pan in a kitchen, one of the first things they tell you is to put the lid on it, okay? Put the lid on the pot to snuff out the air, right? Because the fuel has already caught fire. If you take one of the ingredients of that triangle of fire away, fire's going to die. Okay, but one of the worst things you can do in an oil fire or a grease fire like that is to throw water on it, because that spreads the actual fire. It splatters the oil around. Okay, you see a lot of people take their actual dish towels and try and whip and put out a fire only to have the dish towel catch fire, because the dish towel is made of cotton, which is flammable. It is a fuel. when you have a kitchen fire, the vast majority of kitchen fires like that deal with oil as a fuel. Water and oil are immiscible. It's not that it makes it bigger, it's that water and oil don't mix. So if you throw water onto an actual grease fire, oil fire, what's going to happen is it'll splatter the oil that's already on fire because they don't mix. It will not put it out because you're not extinguishing or getting rid of that actual flame. The last thing, and it's probably the most abstract of the two, because it makes sense that you know this from examples. You cannot have a fire if you don't have any air. Okay? You cannot have a fire if you've got nothing to burn. You know this. But the last ingredient that's necessary for a fire is something called ignition temperature. Okay, and the ignition temperature is that minimum temperature, and we know from chapter 3 what temperature actually is. It's the movement of particles, and it's that minimum level of thermal energy needed to actually sustain an actual fire. Now, when we talk about ignition temperature, we're not talking about the temperature outside. What we're actually talking about is the temperature of the fuel. All right? Or the state of the fuel. If you've got wood that's sopping wet, okay, its ignition temperature it's almost non-existent in that it's going to be very hard for you to actually light that on fire. If you've got a frozen, piece of clothing sitting outside, it's not necessarily going to catch fire like a regular t-shirt would. It's the fuel, it's the temperature, it's basically the amount of thermal energy that the fuel has. Is it going to be enough to actually sustain an actual fire? Okay? Does that make sense? If there's a fire, like back in my hometown, there was a fire not long ago in one of the buildings on the main street in town. One of these just stereotypical little towns with a main street with shops on it. And one of the big buildings there caught fire. So one of the fire crews, one of their jobs was to hose down neighboring buildings. Why do you think they hose down neighboring buildings?
So it'd be harder to catch.
So it'll be harder to catch fire. Because if it's wet, the ignition temperature goes way down. There's way less chance. There's not way less, but there's much less chance for the wood and the brick and the everything else to catch fire in the neighboring building if it's sopping wet. Okay? And water damage you can replace. When something is burned to a crisp, well, it's gone.
That is true.
Okay?